Hello everyone, I'm Cole. Today I prepare very interesting chemical lectures. Yes, chemical reaction such as endothermic, exothermic reaction that are usually detected in our human life. Even some kind of commercial products using these phenomena. So I need someone's help. And then Wada, can you come to and explain something?
Hello, this is Warda. Today I will tell you the several chemicals that already prepared here. The first chemical that already prepared is NaCl or sodium chloride, and the second one is calcium chloride.
Then make sure they are all white chemical substances.
Yes, white
So that's
chemical
why
substance.
it's impossible to discriminate which one is which with our naked eye, right?
That's right, Professor.
Okay.
So, Professor, I
Hmm.
think now is the time you should get blind.
This means just kind of game inside the lecture.
I think so, Professor.
I can guess. Okay, let me.
So I will pour the two chemicals into different glasses that already filled with ice here. And professor should guess which one is which.
Oh, it's very
Okay?
difficult and the water.
Okay, I will start, professor.
Okay, I don't know. And then please let me know after you finish this job and then.
Of course, professor.
Uh, I'm really worried about and then can I guess correctly and then if you got a mistake and then so I'm really worried about it and then I'm very nervous. But the once we know the endothermic exothermic reactions very well, I think anyone can guess which one is sodium chloride, which one is calcium chloride together with ice. Mm, is it done, Wada?
Then, professor, you can open your eyes.
Okay, thank you. Okay, so I don't know which one is which, and then okay, let us start our presentation, the lectures presentation. So before starting, and then we need to talk about the thermodynamics. Thermodynamics is really everything, and then energy. We know energy should be yes conserved. This means and then energy cannot be created and also energy cannot be destroyed during the procedures. But sometimes we can see some kind of destruction, creation, this energy before. No, that one only transfer, right? So that's why you must keep in mind this idea conservation of energy in our universe. Okay, it's time to talk about endothermic. Endothermic. And then comparison exothermic. Exothermic. What about that? From the letter itself, endo. What about enter? When I just see endothermic, sounds like enter, right? Wow. This means, and then we just make one small box. This is a system. And then this surrounding. In this case, and then thermic. This temperature, heat. Enter. Enter means, and then like this one. From the standpoint of the system, right? The heat goes inside. So this is endothermic. What about exo? What about that? Exit. Exit in the one, some building have some kind of fires, and then people try to find an exit. They want to go out. That's why is exo means exit. This means, and then one system here and heat going away. This one. 자, here the one thing, and then you are stay here. 자, you are stay here. 자, and then some temperature. Your body temperature. You have some kind of specific temperature, but this you lose your temperature, and this temperature go inside this system, and then you just feel, no, it's very cold, right? Actually, there must be the temperature, 10 degrees Celsius or 20 degrees Celsius, but this temperature move inside the system. That's why you're going, okay, your temperature must be the 5 degrees Celsius or lower than this one. That's why, I just feel very cold. So what about that? On the other hand, you are here, very close to the system, and here, and then heat coming from this box and the system, and then temperature increase, right? That's why what you feel, is very hot, right? That's why from this one, and then you can simply know which one is endothermic and then exothermic from the standpoint of system. Okay, based upon this understanding, let me draw very important chemical reaction, and then y-axis is potential energy. Potential energy. And then x-axis, this one is reaction. Yes. And then we just make the two different lines. One line here, another line right here. Everything is done. 자, the left side, this one is reactants. The right side should be products. And then these reactant stages become to the higher level for the product stage, and then. So normally the kind of case, and we need overcome, okay, reactants in this one just feel some kind of barriers that we can call this one activation energy. So real reaction just like this, right? Normally. So let me just talking about this one, this side. This is activation. Energy. What about that? The difference between the products and reactants. This height. We can call this delta H, enthalpy value. And this stage, we can call this one transition stage. Transition stage. So that's why one thing change into another things. First of all, we need to overcome a huge barrier like a mountain, and after that, there is some change in heat. 자, in this case, and then heat, yeah, we just take the heat from the surrounding. That's why this energy level become higher, right? Potential energy. So that's why endothermic reaction, this matters. The potential or energy of the binding energy, chemical bonding of the reactants, and also potential energy of the binding, the chemical bonding of a product. This one it should be higher, lower. We can see endothermic reaction, exothermic reaction. Endothermic reaction, reactant to this potential energy chemical bonding reactant is lower than that of products. Okay, that's why here and there we can see the chemical bonding is very, very important. So in the kinetic sense, we can find a very important finding. Delta H value, yeah, is positive. That's why should be higher than 0. On the other hand, we can look at the exothermic reaction. Exothermic, and then we can give the energy, heat. Sometimes can be energy, can be works, can be sonic energy, any kind of form, and then we just donate some amount of energy to the system. That's why the reactants stage is high. Yeah, y-axis is the potential energy, same as the left side image, and then final products right here. Even this case, and then we also encounter huge barrier like the hill, right? This one, activation barrier. So once again, we have to define the gap between reactants and then products. There should be delta H. This stage is transition stage, and then this height will be activation energy. It's very simple. In this case, and then the reactants is very high value in potential energy, but it's decreased. This means delta H value should be negative. It's so clear, right? Sometimes I want to give you one more thing, and then this diagram. Do you know the catalyst? And then catalyst is defined as some kind of substances, something to help the process become easier, and then some slow process become the faster, right? Difficult process become the easier process, and then so it's matter. It's coming from activation energy. So once we add some kind of catalyst in the chemical reaction, this height decrease, right? This red line, this means plus catalyst. Yeah, this catalyst never involve the chemical reaction. These just help the process going very well, smoothly, or not. In this kind of case, and then reduce the energy, right? Activation energy from this peak and then from this one. That's why it become reduced. That's why this process become faster, easier. This is effect of the catalyst, and then here, and then I want to give you some example, industrial or practical example. 자, first one. Did you see cold pack? Cold pack. During summer, and then you sweat a lot. You just feel sick and tired because of the hot weather. Especially this area is very very extremely hot and sticky with high temperature. That's why you just hold on some kind of liquid substances, the pack with some kind of plastic, the transparent the bags, and then this is the cold pack. Once we just activated cold pack, and then it shows some kind of endothermic behavior. Why? The same thing. The cold pack here, we just broken and then mixed together, and then temperature, they all take. So that's why here this temperature will decrease relatively, right? That's why this is very critical things. And then cold pack. The other one, if I take a look at, and on the other side, and then exothermic, this one hot pack. Hot pack means, and then there is something look like a pack, and there's something inside you don't know very well, and then you just scrub each other. There's something happen, and then it can generate some heat, the emission of heat from this the bag, right? And what happened? And then you just feel warm during winter. Yeah, winter is coming in South Korea, and then it's very useful item in your pocket, right? So that's why we can utilize these things very well. This hot pack, actually the constituent of the hot pack is Fe, small fragments of Fe plus O, oxygen. This is a process in corrosion, right? Or oxidation. So these kind of things, and then so corrosion or combustion, and then oxidation. Actually, this word is all identical. So these phenomena are grouped as exothermic reaction. Okay. So what about that? In a street, I just remember the time when I just stayed at Boston, and Boston is an area where really snow a lot, and then all the time, all the street, and during the winter. That's why sometimes the traffic is almost stop and hurts. So that's why, and then some peoples and then spread out some substances to the road or by the car. So sometimes someone just use NaCl, sodium chloride, or calcium chloride. This role is almost identical. The role of these substances, snow, the removal agent. So sodium chloride will be react with H2O. Calcium chloride also react with H2O. And then the result is same. The ice formed on the roads or street will be melt down with easy, and then, right? So it's now my time to give a correct answer, right? This one is the blue one, calcium chloride, and this one, sodium chloride. Normally, and then I have some kind of machine to measure the temperature, but before that, from my naked eye, let me guess. This is the more much water. This one relatively small. That's why I can say from the endothermic, exothermic, this should be calcium chloride. And then the right side, this one, on my right side, your side should be left, and then this one, sodium chloride. I can expect in this way, and then So is it right?
It's right, Professor.
Okay. And just in case, and then we can just in case measure the temperatures by the machine, and then okay, there are some temperature, and then this one. Yes, I can estimate the temperature very well. But the what kind of the snow removal agents can be used? It's depending upon the area. Very very severe weather, like a Siberia, right? And Russia, and then it's really frozen area all throughout the year, and then in the kind of case, and temperature is very very low, so still ice over there. In the kind of case, we must use exothermic. Why? These calcium chloride generates some carried after reaction with water. So that's why melting temperature decrease, easily melt down like my left side, and then. But the sodium chloride NaCl is also very effective, but it's not the too frozen area. Maybe South Korea or Japan. There's some kind of ice on top of some road, and then we can spread it out. And then they just absorb the temperature from the surroundings, and then so decreasing the temperature. Also, last time we just talking about ice cream section. Yeah, freezing point depression, and then. So now I just talking about and then endothermic, exothermic reaction. This is very useful, and also you can find so many application in our human life. So I hope you can enjoy today's video clip, and then next video, and then see you next time.